Hello, ladies and gentlemen. Welcome to Unit 7 seminar. Obviously, since this is a pre-recorded seminar, there's no music associated with this. However, the music that I would have played is a very haunting piece of music. So, with that, let's go ahead and move forward. We'll begin by reviewing Unit 6. Some key things we talked about in Unit 6 was consumer surplus and producer surplus. And you might recall that consumer surplus is the extra savings that some people get because they would have been willing to pay more than what the equilibrium price was in the free market or perfectly competitive market that we were studying. Producer surplus, the green PS, is the extra profit that some producers would have made or could make because they were willing to accept a lower price than what the equilibrium price was set in our perfectly competitive market. So that we understood. From there, we looked at what happens when a price floor is established. And remember, a price floor is the lowest price that a supplier can sell that product for. Normally, it's set by the government, and normally this is an action to assist suppliers in making more money than they could have made at the equilibrium price. And you'll notice here that the black arrow for the price floor is well above the equilibrium price where the supply and demand levels cross. Now, what we find immediately, though, is at this new higher price, as you see in the blue arrow, the consumers are only willing to buy less of the product. However, at this higher price, the suppliers want to supply a lot of the product. And so as you see with the bracket at the bottom, the purple bracket with the red insert, you see that there is too much product made by the suppliers and they're unable to sell that extra product. Now, if we look at the surplus picture, what happens to the consumer surplus and supplier surplus, we see a couple things immediately. First off, we see the consumer surplus, the yellow triangle, the CS, is relatively small. That's because at this new higher price, there are fewer and fewer consumers willing to purchase the product at a higher price. We notice that there's a large area of green, which is the PS, the producer surplus, but we notice it's broken into two shades of green. The lighter shade was part of the usual producer surplus that the producers would have made if the product had sold at equilibrium price. But because the government has set this price floor above equilibrium, we now have that darker shaded green area called PS, and that extra producer surplus came from the surplus that would have been the consumers if there had been no government interference in the free market. Now, because the blue arrow going down to the 2,000 quantity at the bottom indicates the total amount that consumers were willing to purchase, what we now find is the red triangle that says DWL stands for dead weight loss. And what that is additional product that would have been sold at the equilibrium price, but now is not being sold because the government had set a higher price floor. And so that was part of our surplus. And then the purple triangle that says extra wasted is additional product above and beyond what would have been produced for the at equilibrium if there is no price floor. That's additional that the suppliers are producing because they want to make more money. And so again, it's extra wasted product that is a surplus of product that's not being sold. Again, the whole idea of a price floor is for the government to try to help the suppliers make more money. Now, carrying it a step further, okay, another variation on this is where the government says to the suppliers that the price floor is above equilibrium, but the government will purchase any product not sold to consumers. This was the basis for some of the farm support programs that the government has used over the years. Well, now, from the producer's standpoint, they do have that large green triangle area. And why? Because they're either going to sell the product to consumers, where the blue arrow goes down to the 2000, or the remainder of the product they're going to sell to the government. And this is one way that at one time that the government had a lot of surplus product, and they would give the product to various people, foreign countries or whatever. And if you paid attention to those 9 videos that I did for the supply and demand for Unit 3, you might recall that in one segment I gave a discussion about the cheese that my ex-mother-in-law and father-in-law were able to get through the dairy supports back in Pennsylvania years ago. And basically the government bought the excess cheese that would be this excess area, and then they gave it to the elderly folks who were on Social Security. Well, the problem was it was way more cheese than my ex-mother-in-law and father-in-law would ever eat, and so they gave it to my ex-wife and I when we were still married. And we always had plenty of cheese. We'd get these 5-pound blocks of cheddar cheese when we'd go home to visit them. So therefore, we weren't buying cheese. So in addition to that, where does the government get the money to buy this excess product? Well, they have to collect taxes for that. So again, that's you see the red and purple bracket at the top, where they have to collect taxes for that. Now, there's another variation of this that the government will sometimes do when they interfere with the market. And this would be a situation where instead of the government buying the excess, what they do is they tell the suppliers that, yes, we're going to set a target price. It's no longer a price floor. It is a target price. And what they do with this target price is, obviously it's set above the equilibrium price, but the government tells the suppliers, supply what you can at the equilibrium price. And what you're unable to sell at that equilibrium price, we will give you the extra money between that equilibrium price you were able to sell at and our target price. So here you see the equilibrium price would be $20 and the target price $30. And we see that 4,000 were sold to the consumers at that equilibrium price of $20. So at the end of the period of time, the year or whatever, the supplier goes to the government and says, "Excuse me, government, I sold 4,000 at $20, but you promised me a target price of 30, so I'd like to collect my check for the $10 for each of those 4,000 that I sold." And so that was an extra payment by the government to help the suppliers. And again, where did the money come from? It came from taxes. That's the only place the government gets money at. Okay. Now, a different variation completely is what we call a price ceiling. A price ceiling, unlike a price floor or a target price, a price ceiling is a price lower than the equilibrium price, in which the government is now trying to assist the consumers to get a lower price. Now, what do we see here? Well, we see that now the producer's surplus is much lower, because at this low price, in this case $15, well below the $20 equilibrium price, the suppliers are not willing to supply nearly as much. So where the kind of pinkish arrow goes down to the quantity of 3,000, that's the amount that suppliers are now willing to supply at this lower price. So now there are still some suppliers who would have been willing to supply at an even lower price. So we have the small green triangle in the bottom left that is the total amount of producer's surplus. Now you notice we have the bright yellow part of a triangle up above. Those are consumers who would have been willing to pay more than the equilibrium price, and so they're getting some extra savings or consumer surplus. But now we see a very light yellow rectangle below that is the additional consumer surplus, because now the consumers don't have to pay the equilibrium price, but instead they only have to pay the price ceiling. And so where that extra consumer surplus came from is it came from what would have originally been the producer surplus in a perfectly competitive market. Now, because the producers at this lower price are willing, in this example, only willing to sell or supply 3,000, where in the equilibrium situation they would have a perfectly competitive equilibrium situation, they would have been willing to supply 4,000. So we see a red triangle area that represents part of the product that was never sold because the suppliers would not produce that amount. And again, we call that dead weight loss. Now, we also went through how to calculate these various consumer surplus and producer surplus, and we followed a format similar to what the assignment problem was going to be, and we saw that we had to compute the area of a triangle. We used the formula, area of a right triangle, and we used the formula height times base divided by 2. And obviously you do what's inside the parenthesis first, and then you do the division that's outside the parenthesis. So you see the calculation here, and again I went through that in great detail last week. That would be the area of the triangle for consumer surplus when there was no government interference and we were dealing with a perfectly competitive market. Now, when we install the price ceiling, okay, I'm sorry, in this case it's a price floor. My mistake, sorry about that. So we put in the price floor to aid the suppliers. Now the consumer surplus is much smaller because there are so many fewer consumers willing to would have been willing to pay a higher price than this price floor. So you see we compute the area of this much smaller triangle using the base times the height and dividing by 2. For the producer surplus when there's a price floor, now we have a much larger triangle. And again, in this case, the government is purchasing all the excess. And so we went over the formula for how to compute that. Again, using the same formula, height times base, multiplied together, divided by 2. And then we looked at how much the extra money the government would have to collect in taxes in order to buy this excess product. And so we saw the computation there was simply number of pounds or whatever the quantity is that the government has to purchase that people did not, or consumers did not purchase, times the price floor. So that's a very straight multiplication. And again, the place the government gets that money from is by collecting taxes from you and me. So obviously, if you have any questions about this, make sure you get in touch with me and I'll be happy to go through it with you. So what we want to cover tonight, we want to look a little bit more this time at what drives suppliers. So we're going to look at costs. And you remember that our supply curve, and again realize it's a straight line for a simple model, but it would really be a curve. That supply curve is created in that upward to the right slant because of the costs that the suppliers incur in producing the product and compared to the price that they're able to get for selling that product. And remember, cost and price are totally unrelated. You have a certain cost for producing it, but the price is what you can sell it for in the open market. So there are several costs that we're going to look at. We're going to look at total and average total and variable and average variable and fixed or average fixed and marginal costs. So we're going to learn a lot about costs. But to start off with, we need to talk a little bit about a business. Okay, so we're going to pretend that our class is starting their own bakery business. Okay, so if this were a live seminar, I'd be asking you to tell me what are some of the costs that you can think of that would be involved in running this business and starting it and running it. So I'll show you what some of the costs have been that students have told me over the time that I've been teaching this. So we have some common things. Obviously, you need a building. You need to have the correct licenses or the government won't let you operate. You need to pay a baker. You need to buy the ingredients. So there are several things that we have here that we have to spend money on to operate this bakery. So let's take a look a little bit more detail. These costs on the left, the rent, the license, basic utilities, that's the electric for the building, basic security, and the equipment in the building, the lease payments on the equipment. Okay, the key to these is it does not matter if our bakery makes 1 pie, 10 pies, 100 pies, or 1,000 pies in a month. We still have to pay those costs. Okay, so they are created and exist regardless of how many pies we choose to make. Okay? And again, for simplicity's sake, I'm saying our bakery is only making pies. So we call these costs that don't change, or don't change based on the quantity produced, we call these fixed costs. Now, looking at the other side, we have ingredients and the labor for the baker, for salespeople. The utilities direct, this would be the extra gas to heat the oven when you're baking pies, the extra cost of electricity to run the freezer to keep your ingredients cold, those kinds of things. And they relate directly to how many pies you're producing. If you produce more pies, you're going to have more cost of ingredients. You're going to have more cost of labor for your baker and your salesperson. Fewer pies you make, you're going to have less cost in those areas. So these costs change strictly based on how many pies we choose to produce. So they are called variable costs. Okay. Now, remember also that because we're dealing in what's called a perfectly competitive market for our supply and demand model, we're assuming that our bakery is a price taker. What does that mean? Well, it's a small operation. There are many other bakeries in a large community, and our customers know what the other bakeries are charging for their products. And assuming that there are several bakeries that make the exact same kind of pies that we make, so therefore we do not have unlimited freedom in charging whatever price we want. We are constrained by the prices that our competitors would charge for equivalent products. And our customers know what our competitors would charge. So there comes a time that if we raise our price too much, that instead of our customer coming in our store, they'll go maybe a few blocks further and go to the other bakery. So we are therefore a price taker. We cannot set any price we want without consequence. Okay, so the question for us as producers is, what level should we produce at? How many pies should we make? Well, obviously we need some numbers to go with this because we got the baker in the back working. So now it's time that we put this whole system to work. So remember that we had our fixed costs. So the first number we're going to compute is what we call average fixed costs. And we want to explore an idea called cost spreading. And so let's assume for a minute that our rent and our license and the basic utilities and all those things come to $1,000 a month. Now remember, if we're running our bakery and we decide to go on vacation for a month, okay, we still have to pay that $1,000 of fixed cost. Whether we do any business or not, we got to pay it. So that's our fixed cost. So imagine if we only made 1 pie a month. How much fixed cost how much would we have to charge for that pie just to cover the fixed cost? Well, obviously we'd have to sell it for $1,000. Now, I know that's ridiculous. It's almost as ridiculous as if we only made 2 pies, and therefore we could sell each one for $500 to recoup our fixed cost. See, all we're doing is dividing the number of whatever it is we produce into our fixed cost to see what share of that total fixed cost each unit of production should bear. We call that average fixed cost. So obviously, the more pies we make, the less fixed cost each pie has to bear. So we're spreading that fixed cost over more and more pies. So you can see by the time we get to 500 pies, we're down to $2 a pie. If we can get to 1,000 pies in a month, now each pie only has to generate $1 to cover our fixed costs. Okay, so we can put it into a simple chart, and what I want to do is just show you a quick graph of what the curve would look like for our average fixed cost. And what we find is we start off with a very high average fixed cost, and then the curve swoops down and gets closer and closer and closer to zero. But even if we made 10,000 pies in a month, each pie would still have 10 cents of that $1,000 of fixed cost. If we made 100,000 pies in a month, each pie would have 1 cent of that fixed cost, and so forth. We never get to zero. Okay? No matter how many pies we make, each pie would always, they would have a smaller and smaller and smaller share. It'll get closer and closer and closer to zero, but we never quite get to zero. Okay? So we see what direction our average fixed cost would look. Now, remember we were talking about our variable costs. Well, I made up some numbers here for you. We're going to assume that we're paying our baker $15 an hour. Our salesperson, will pay him $10 an hour, a little bit above minimum wage. Utilities, we estimate we're going to spend $2 an hour for the oven to run to bake pies with. And then we've got some cleaning help and some other help. We will put that at current minimum wage, which is $7.25. And that comes to a total of a little over $34, but we're assuming that we can make 21 pies in that hour. So each hour we can make 21 pies. Okay? Each hour is going to cost us $34.25. Each one of those pies is going to bear $1.63 of the variable cost. Okay? That's getting our ingredients. Well, no, we haven't even gotten ingredients yet. Let's talk about ingredients. The flour and the sugar and those things that can be measured directly per pie, we're going to say is going to come to another $2.37. So our variable cost per pie ends up being $4 per pie. Now, that's true if we make 10 pies. We only work our baker and our salesperson for a half hour. Okay, that's true if we make 42 pies. We run them for 2 hours. Each pie is going to have $4 of the variable cost. Okay, if we were to plot our average variable cost in this situation, then we see that each pie bears another $4 of variable cost. We end up with a straight line. The cost does change based on how many pies we make, but each additional pie bears the same amount of variable cost as the pie before it did. Now, hold that thought for a minute, because we're going to shift gears completely. There is another situation we can encounter, and I'm going to use a farming example, so we're going to change numbers completely. What we're going to do now is talk about a farmer growing crops out in the field, and if there's that one farmer doing the work, that one laborer, the chart on the right tells us that we will produce 19 bushels of wheat in this case. So one worker does 19 bushels of wheat. Well, we need more wheat than that to make more money, so we hire a second worker to help that first worker. So now we've got 2 workers out in the field. But notice the total production is no longer double the 19. In other words, we don't get quite double what one person got. Now with 2 laborers, we get slightly less. So the total doesn't go to 38, it only goes to 36. Why would this be? Well, maybe the second worker is learning the job and is not able to quite produce as much as the expert worker. And the expert worker has to spend more time training the new helper. So therefore, that expert worker is not quite as productive. So combined, the 2 of them are making less total than twice what the one person could do. Now we can add a third worker, and we see again we have an increase, but we don't end up with 3 times what the first worker would. Why again? Well, we can imagine that there's the workers have to spread out over the field. They have to share tools. They have to share resources. So each one cannot, all 3 do not do triple what the first one would do, and so forth. We do the same thing. Now notice that when we go from the 7th worker to the 8th worker at the bottom of this chart, now we've gone from 91 to 96. We've only increased our output in bushels of wheat by just 5. But remember, the first worker, we increased from 0, we got all the way up to 19 bushels of wheat. You say, why would this be? Well, here, again, we have so much resources available for this job to be done, and the workers have to share the resources. So now maybe there's so many of them that they're bumping into each other, and they're not getting as much work done as a single worker could do. Okay? So we find this in a wide variety of labor situations, and it's referred to as diminishing returns to labor. Okay? So what we see is our output per worker is decreasing as we add more and more workers. So let's take a look at the exact number difference. Okay, how did I come up with this? And in economics, remember, we have some terms that we're learning, just like we're learning a foreign language. So we're going to call this the marginal product of labor. And all we do is take the quantity we produced, okay, and the quantity we produced with the worker before, in this case no workers, and the total quantity we're producing now, we subtract the 2, and we find that 0 from 19 leaves us 19. This first worker is giving us 19. When we add the second worker, our total output now is 36. When we subtract the 19 we got with a single worker from the total output from 2 workers, we find the second worker contributed an additional output of 17. And we can continue the computations the same way, and we find out how much each additional worker is contributing to our total output. And we call that the marginal product of labor. Now, we can plot the curve for our total output. And again, you see it's an arcing curve. In the beginning, if you look at the little arrows off the 2 points on the far left of that curve, where we added the second worker, and we see that we have a pretty high gap where that second worker is adding an awful lot. Okay, notice the horizontal arrow is exactly the same. It goes from 1 to 2. So we added 1 more worker. But the vertical arrow going up to that point is the 17 bushels of wheat that worker contributed. Now, if we go to the similar arrows on the right side of that curve up near the top, where we added the 7th worker, okay, and we see that the 6th worker gave us a certain amount of output, but the arrow on the horizontal arrow going over from the 6th worker to the 7th worker is exactly the same length as the horizontal arrow from the first worker to the second worker. That hasn't changed, but now we find the vertical arrow of the second group, the 7th worker, is much shorter than it was for the second worker, because that seventh worker is now only contributing 7 bushels compared to the 17 that the second worker contributed. Again, demonstrating that concept of diminishing returns to labor. Now, we can go a step further. Let's make sure I'm in the right place here. And we can plot the curve for that marginal product of labor, and we see a descending straight line in this example. Okay? And so, pretty straightforward. But what we really want to know, okay, and again, we'll go back and measure our total output. We're always looking at what our total output is because we're measuring what is the cost of our output. Okay, and we're going to compare how many laborers it takes. So in the column you see the number of workers. Okay, now we're going to assume that each worker cost us $200. So the first worker cost us $200. The second worker cost us $200 more. So now in order for us to get that 19 bushels, we only had one worker. That cost us $200. To get 36 bushels, we end up with $400 because we have 2 workers now, okay, and so forth. By the time we get to the 91st bushel to the 96th bushel, we see we jump from $1,400 of variable cost to $1,600 of variable cost. And again, the only thing we're saying is variable is our labor cost. That's the only thing that's changing. But what's happening is because our output is getting less and less, we find that our variable cost per bushel is increasing as we increase our output. Okay? So what we can do, let's make up a fixed cost. Let's say that there's a fixed cost, let's call it rent on the land, of $400 a month, okay, or whatever the period of time is. Those fixed costs are going to stay the same no matter what. Now, it's going to be a simple matter to compute what the total cost is. And we can come over and just add the variable cost and the fixed cost. So we know total costs are quite simply the total of fixed cost plus variable cost. Okay? We add the two together. If you were given total cost and the problem, the assignment, told you what the fixed costs were in the words, okay, and then they give you a column of total costs, but they don't show you the variable cost, well, you know immediately how to compute your variable cost, because all you have to do is subtract the single fixed cost from each of your total costs, and that will give you your variable cost column. Pure math. Okay, so going back to this, we can plot this total cost curve, and we see that it's, in this example, it's not a straight line anymore. Now it's an increasing arc. Okay? And the arc is getting steeper and steeper as we add more and more workers. The reason being is that it is a diminishing returns to labor. Now, I'm going to ask you to shift gears one more time. We're going to abandon our wheat example, and we're going to go look at something else called salsa. And again, these examples should be in your textbook if I'm not mistaken. But what I want to do now is get to another way of measuring cost, what we call marginal cost. So, taking what we already know, we have a quantity of salsa, number of cases, and notice that we increase each time by 1 case. Notice our fixed costs. Fixed costs are the same no matter how many cases we produce. It's $108. Then we have variable costs, and those variable costs, go up as the number of cases are increase. We know how to compute our total cost. That's our total cost is the fixed cost plus the variable cost. So we've got some numbers to work with. Okay. Now, what we want to do is measure what's called variable cost. For variable cost, what we're looking at is the change in total cost by adding one more case of salsa. And this would be true no matter what we were measuring. Anytime you see marginal cost, it is how much is the cost of the last one we produced, just that one. So to get the marginal cost in this case, what we're going to do is we're going to, and I've got them all shown here. So we start off, let's look at the first case. We go across to the total cost of the first case. Well, it's $120, which is our $108 of fixed cost plus our $12 of variable cost. Okay. Now, we had $108 of fixed cost even when we had zero production. Now we have a total cost of $120 when we produce one case. So if we subtract the $108 from the $120, we get $12 left over as the marginal cost of the first case. Now let's go down and look at case number 10. Okay, case number 10, I realize the 10 is hidden by the oval, the green oval around the number of cases, but you can tell where it is. Okay, we see that our 10th case had a fixed cost of $108, just like all the rest, and it had $1,200 of variable cost because we now had 10 cases. If we subtract the total cost of 9 cases, which in this case is $1,080, from the total cost of 10 cases, we find out, which was $1,308, we find that the total cost, the marginal cost of the 10th case was $228. Okay. So we could see how the numbers are computed. This should give you no grief whatsoever in computing. It's an easy number. And so marginal cost, the key to marginal cost is, remember, it is the total amount of the cost for one unit less minus the total cost, or taken away from the total cost of this unit. Now, what happens if you have, instead of one case, 2 cases, 3 cases, what happens if you had zeros on the end? Let's say the first was 100 cases, and the second one was 200 cases, and the third one was 300 cases. Well, still, we want our marginal cost to be the cost of the very last case. So, if we look at the case number 1 and case number 2, and assume for a minute that they were case 100 and case 200, okay, and we still have the same total cost. So we see that case 1 had a total cost of 120, or case 100 did, and case 200 in this example would have a total cost of 156. That would give us 36 for the marginal cost of 100 cases, the second 100, but we want to know what the marginal cost is of a single case. In that case, we'd have to divide, that situation, we'd have to divide 100, because that's how many cases changed between 1 and 2, into the $36 marginal cost of that group of cases. And that would, obviously, we divide by 100, we're going to get, what, 36 cents would be the marginal cost of the 200th case. So just remember that in case you get a situation where you're dealing with a number instead of a single change of 1. Instead, you're dealing with a change of 100 or 1,000 or whatever. Okay, moving on. So we want to compare what is this thing marginal cost compared to total cost. Okay. Well, we see our total cost curve in this particular example. All we did was take the total cost column and plot it, and we see we have that upward sloping or upward sweeping curve that's getting steeper and steeper because our total costs are increasing. Okay? But when we measure the marginal cost, because in this example we do not have that diminishing returns to labor, we find that our marginal costs are increasing in a straight line. Okay? So each case has, that much more marginal cost. Okay, continuing on. What about averages? How do we get averages? Well, we'll stick with our salsa example for a few minutes. Okay, and we can get our average total cost by taking whatever that total cost that they gave us and just dividing the number of cases into it. Okay, so for instance, if you had 2 cases and for an average total cost of $78, okay, all we did was divide the total cost at $156 and divide it by 2, and that gave us our $78 for our average total cost. So all we're doing is taking total cost and dividing it by the quantity to get average total cost. Now we have, and of course you can see what the plot looks like. In this case it starts out very high when we have a low quantity that we're producing. It comes down to some low point and then it starts back up again. You say, how can this be? Why? Well, remember that we're in the total cost includes fixed cost plus variable cost. So when we're computing average total cost, remember the more and more units we produce, the more we spread out those fixed costs. And so we have the fixed component getting smaller and smaller and smaller as we produce more and more and more units. But then we get to a point where the increase in the variable cost is getting so big that it starts overpowering that decrease in the average total cost, or average fixed cost. So therefore our average total costs start increasing. Okay. So the next one we want to look at is average fixed cost. All we do is take whatever they tell us the fixed cost is and divide it by the number of cases produced. Okay, very simple, or number of units produced. So fixed cost divided by quantity. And then we have average variable cost. Now our variable cost can be a little different, okay, as we saw. And so what we're going to do is compute what our whatever the variable cost is. And again, we have the variable cost in the upper table in the upper left. And all we do is divide it by the number of cases that we're producing, and that gives us our average variable cost. So variable cost divided by the quantity. Okay, if we combine these cost curves, we have our marginal cost curve, in this case using this gourmet salsa, is the straight red line. We have the average fixed cost, which is the very light colored line that starts high and goes very low and keeps getting lower and lower and lower. We have our average variable cost, which in this example are increasing the same amount for each additional unit that we produce. And we combine the average variable cost and average fixed cost, we get our average total cost. It's ATC, or average total cost, is merely the total of the average fixed cost for that quantity and the average variable cost for that quantity. Okay, so now these numbers, these curves come from a very simple example. Let's take one more look at what some more realistic cost curves would look like. And here I've just given you the average variable cost and average total cost. I didn't bother demonstrating the average fixed cost, but we know it keeps getting smaller and smaller and smaller. Okay, but I did show you how the marginal cost changes too. And we'll see in next week's unit why these are important, why these costs are important, and what we can do with them. So that said, again, if you have any questions, make sure you get a hold of me. It's important to do that. And this week you have chapter 11 to read. Hopefully I've given you a preview of the information that you're going to need to really key in whenever you're doing that reading, and you can focus on it. Of course, we have our discussion and our assignment. Our discussion this week is going to take a look at what happens if we have a change in property taxes. What's going to happen to our average fixed cost, our average variable cost, and our marginal cost. Okay? And it's going to ask you to discuss that. So we'll get a feel for how comfortable you are with those costs. Again, make sure you look at my hints for this week's assignment. They should be a big help to you, and they may even help in the discussion thread. You know the drill on what you have to do for the discussion to get the highest grade. Okay, your assignment for this week is also going to look at those fixed costs and variable costs and total costs. It's going to look at the averages. It's going to ask you about minimum cost output level. What minimum cost output level? It's the level you would produce when the average total costs are the smallest. Now, you can do that off a graph, but more likely you're going to look at the table of average total costs, and you're going to skim down that table until you get to the smallest number there. And it may not be the last number. The numbers may get just as this curve shows. The numbers are getting smaller, smaller, smaller. They get to the very smallest point where the black lines intersect, and then it starts getting bigger. Okay? So, and remember, the minimum cost output level is the quantity where that cost is the lowest. So all you have to do is go down the average total cost column, find the smallest number, look over to the left, find out what the quantity is. Then it asks some questions about perfectly competitive industry or monopoly. It seems to me that question has been done away with on this assignment. So don't hold me to that, but it may have been done away with on this particular assignment. So if you don't see it, don't worry. If it is there, we'll talk about it. Okay, so with that, you know how to contact me. Don't be afraid to contact me if you need further help, if you don't understand this or you have any problems you're concerned about. So with that, thank you all very much for attending the seminar, and I should see you in the discussion threads this week and in next week's seminar. Thank you.